going on, everybody? It's Mr. Gustin back in the chemistry classroom here. Today we're talking Lewis structures and how we can go ahead and construct those from Lewis dot structures of our atoms. So we've been talking in class a little bit about atoms, and now we're thinking about how those atoms join up to form molecules. So we've got three covalent molecules here on the board. I've got my periodic table here to help me. The first thing you should have is a thing to write on and make sure you have your periodic table with you. It's really challenging to draw Lewis structures or construct models if you don't have your periodic table. So in class, we talked about some of the steps that would go along with writing Lewis structures. So let's go ahead and review our steps for drawing Lewis structures. The first step we have is to go ahead and draw the atom with the valence electrons. So the first step we have, and we're going to use water here, H2O, as an example, but the first step we have is to draw each atom in a molecule with the appropriate valence electrons. So let's go ahead and do that. So hydrogen is one of the atoms, and oxygen is another one of those atoms, and hydrogen is the third atom. It's H2O. So if I look over here at the periodic table, I need to figure out how many valence electrons they have. So hydrogen's in that first row, which means it has one valence electron. So I'm going to go ahead and just put one valence electron on my hydrogen here, and one valence electron on my hydrogen there. Then I'm going to come over here and check out oxygen. Let's find oxygen. Oxygen is way over here in row 8, or it's element number 8, which means it has 1, 2, 3, 4, 5, 6 valence electrons. So I'm going to go ahead and draw my Lewis structure for that and put 1, 2, 3, 4, 5, 6, 7. I'm sorry. It only has 6. 6. There we go. I got carried away there early in the morning, okay? So there's my first step. Draw each atom with the appropriate valence electrons. Second step, determine how many total valence electrons each atom wants. And so that's pretty easy to do here, right? There's only a few exceptions. Everyone wants 8. Every element on the table wants 8. The 3 exceptions are hydrogen only wants 2. Helium only wants 2, and boron the moron only counts to 6. It only wants 6 total valence electrons. Everybody else wants 8. So let's see who we have here. Do we have exceptions in our model here? Yeah, we do. We have hydrogen. Hydrogen's only seeking 2 total valence electrons. Same with this hydrogen, and this oxygen's looking for 8. Now this oxygen has 6. It wants 2 more. And the word covalent literally means to share electrons. So if hydrogen is seeking 1 and oxygen is seeking 2, there's going to be some sharing of electrons, okay? So hydrogen might share this electron with oxygen, and oxygen might share 1 electron with hydrogen. We circle that just in our work to say, hey, those 2 electrons are going to be shared between hydrogen and between oxygen. And when we share both of these electrons, 2 electrons kind of are on hydrogen, and then we get that pair of electrons also kind of on the oxygen. So oxygen gets an extra electron and hydrogen gets an extra electron. So this hydrogen technically now has 2 valence electrons, and that's what it's seeking. That's what it wants. So it's got 2 valence electrons here. If I do the same thing with the other hydrogen and I share those 2 and I count this up, well, this hydrogen has 2 and that hydrogen has 2. And now this oxygen has 1, 2, 3, 4 electrons stored in bonds. And it has 1, 2, 3, 4 electrons in what we call lone pairs of electrons or non-bonded electrons. Those are here. So this is my water molecule when I'm done. It's H bonded to oxygen. Oxygen has 2 lone pairs bonded to the other hydrogen. This is the structure of water based on my steps. So I determine how many each element or each atom wants, and then I pair non-paired electrons. These are known as bonds. Okay? And then my last step, my check step, would be to count electrons to double check. I'm going to call it octet or duet. Okay? So that's one. That's our first example. Let's try these steps again with two different molecules. Let's do it again. So you can pause it now. Here are my two examples, CH4, NF3. You can pause it here, give it a try, or if you're still confused, do it with me. But here we go. Let's start with CH4. Carbon is here. It has 4 valence electrons. 1, 2, 3, 4. Each hydrogen has 1 valence electron. Notice what I'm doing, right? When I see that there are 4 hydrogens and 1 carbon, I'm putting carbon in the middle. Usually the one written first is my central atom, so I'm kind of putting that in the first spot. Also, anytime there's non-paired electrons, unpaired, not a lone pair of electrons, I'm kind of pointing those towards each other because I assume they're going to eventually like link up or create bonds. And so let's see here. Every hydrogen wants 2. Carbon wants 8 because of the row it's in. And so let's just start sharing. I know it's CH4. I know every hydrogen has to somehow bond to the central atom. So I'm just going to start sharing and then see where I'm at when I'm done. Okay? So now I've got CH4. Everything's bonded. Let's see. This hydrogen has 2 electrons in the bond. This hydrogen has 2 electrons in the bond. Same here, same there. And this carbon has got 1, 2, 3, 4 bonds on it. 4 bonds, 2 electrons in each bond. That leaves me at CH4. It's 8 electrons. Here is my Lewis structure. Carbon with 4 single bonds to one of the 4 hydrogens. That's my answer. And again, I'm just figuring out how many electrons these atoms have, pairing them up to make sure they reach their octet. If you want to try NF3 by yourself, pause it. If not, we're doing NF3 right now. So nitrogen, where's nitrogen? Element number 7, it's got 5 valence electrons, so 1, 2, 3, 4, 5. Fluorine has got 7 valence electrons. I'm going to put the fluorines near each of these single electrons on nitrogen. Oops, I didn't do it there. I guess I'll move this around. Hang on. There we go. That's 7. All right? So I know every fluorine has to bond to nitrogen, so I'm going to start by just kind of like pairing things over to nitrogen and seeing what happens. So these two can share, these two can share, and these two can share. Let's count it up. Fluorine's got 1, 2, 3, 4, 5, 6, 7, 8, and it has that at every fluorine. This nitrogen's got 1, 2, 3, 4, 5, 6, 7, 8. Everyone is happy. There are no exceptions here. Everyone is good. So here's my structure. N, F, 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 and then each of these fluorines have lone pairs of electrons, and you can't forget the lone pair of electrons on nitrogen as well. It's hard to see, but there's a lone pair of electrons there on nitrogen, okay? These are just 3 pretty basic examples of Lewis structures. You should be able to take these basic steps and extend them into many, many, many Lewis structures, into really large Lewis structures, as long as you take them one kind of group at a time, okay? So I hope this helps. If you have questions, ask in class, drop in the comments, that kind of stuff. Otherwise, see ya!